Welcome to STEM School. We'll be taking A-Level Mathematics Year 12, Unit 1, starting with Algebra. The recommended calculator is FX991EX class width. The topics covered will be 1. Proofs, 2. Algebraic expressions, 3. Indices, 4. Surds. Under proof, we'll be looking at simple proofs, odd and even numbers, proof by deduction, proof by exhaustion, disproof by counterexample, and then the exercise. Under algebraic expressions, we'll be looking at expanding brackets, factorizing, difference of two squares, dots, algebraic fractions, and exercise. Under indices, we'll be looking at laws of indices, then exercise. Under surds, we'll be looking at laws of surds and exercise. Right, so we're going to start with proof. The first thing we look at proofs, simple proofs, proof by deduction, proof by exhaustion, disproof by counter example, and exercise. So we'll start with simple proof. First, we define an odd number and even number. So we define even number and odd number. Any even number can be represented as 2n, and any odd number can be represented as 2n plus 1, where n is an integer. It doesn't have to be n. It could be any letter between A to Z. It could be even a Greek letter. So you could say an odd number is 2 alpha. An even number is 2 alpha. And an odd number is 2 alpha plus 1. So when you're defining any odd number or any even number, it is always best to refer to as 2n for even number and 2n plus 1 for odd number. Definition of an integer, just to remind you, is a positive whole number zero and a negative whole number. So plus 3, 0 and minus 3 will be an integer. So now to write example of an odd number, so let's try an even number here. So even number, well, we're using plus 3. If we multiply plus 3 by 2, so 2 times 3, because n equals plus 3 or 0 or 2, so even number is 2n. So 2 times 3 is 6. You can see that's an even number, even though we use odd number to derive an even number. So this is, in this case, is an integer n, where n equals 3. So we got the even number of 6. And for 0, well, 0 times 2 will still be 0, and 0 is still an integer. And minus 3, so if you do minus 3 times 2 will become minus 6. It's still an even number of negative even number. Now to try that with odd number, well, we got 2n plus 1. So if we have n equals 3, so that would be 6 plus 1, and that will be 7. And 7 is an odd number. 0 plus 1 will be 1, and 1 is an odd number. And minus 2, well, it's minus 6. Minus 6 plus 1 will be minus 5. And minus 5 is an odd number. So now let's do some examples. We need to prove that the sum of two even numbers is even. So that's an example to do now. We need to prove that the sum of two even number is even. Well, first of all, let's talk about what is sum. So in mathematics, summation means addition, which is plus. Difference is take away, minus, which is minus. And product is times, which is multiplication. And quotient which is divide so you got the numerator and denominator, so that's divide, numerator, denominator. So quotient is divide. So these are the operators that we need to remember. So these are operators that we need to remember. The sum sometimes is called sum, which means summation. So that's addition and that's plus. So the question here is the key words we're looking for. Obviously we need to prove sum of two even numbers. When we add them together, we get even number. The best way to start with this one is to write a definition for an even number. So an even number of say 2k. 2k is an even number, and if I'm adding that to another even number of 2p, in this case, well, even number of 2k plus 2p, I would get, well, 2 is a common factor, open back bracket k plus p. Remember that in this case, k and p are integers. So if we then add k and p together, with k plus p will give us another integer which we can call m, and therefore we have 2m. Now 2m is 100% an even number from the definition of an even number. So therefore the what we just proved is that even plus even will give us even number. Right, so let's do example B. This time we're going to prove that the sum of an odd number and an even number is odd. So now we're going to prove this. Well, all we need to do now is to write down an odd number and an even number. So let's write 2m as an even number plus 2n plus 1 as an odd number. When we add this together, the proof says we should get odd number. So let's try and do this. Well, in this case, I have got 2m plus 2n. 2 is a common factor in the first two terms. So 2m plus 2n will be 2 into bracket m plus n plus 1. So that will be even plus odd. And in this case, remember that where m and n are integers, but let m plus n become p, where p is another integer. Therefore, I'm going to have 2p plus 1. And therefore, 2p plus 1 is odd number. Okay, we're going to do example C. Here we need to prove that the product of two odd numbers is odd. So the product of two odd numbers is also the keywords. A product, two odd number, we got odd numbers. So we need to define the first odd number. So we're saying odd times, product means times, odd should be equal to odd. So that's what we're trying to prove. So in this case, we need to define the first odd number, which is 2m plus 1. We'll put that in a bracket because we got binomial here, two terms in a bracket. And then we got another odd number here, so we can call that 2k plus 1. Again, we put in a bracket because we got binomial here, and so we times in both of them together. So what we need to do is cross multiply there. 2m times 2k. Remember that where m and k are integers. So 2m times k, so 2m times k will become 4mk. 2m times 1 will become, so that'll be plus 2m. 1 times 2k will be plus 2k. 1 times 1 will be plus 1. In this case, I have got 4mk plus 2m plus 2k. 2 is a common factor here. So if I take 2 out, so I'm going to have 2mk plus m plus k plus 1. So if I let 2mk plus m plus k equals p, where p is also an integer, so where p is an integer, therefore I'm going to get 2p plus 1, and that's odd number. So I've just proved that when you multiply an odd number with an odd number, you should get an odd number.